19 marks, mechanics question. So many marks, it's enough to cook a whole country. So, let's go step by step. Mechanics is super simple. Just remember, it's all about the triangles, isn't it? A particle of mass 4 kg is on a rough plane. I've kind of abbreviated the whole yap that they put in these questions. So, particle of mass 4 kg is on a rough plane, connected to another particle of mass 5 kg, hanging freely by a light inextensible string. So, let's start editing. So, a mass of 4 kg. So, down we have 4g. Remember, we draw long lines. And then we have 5g. This thing's resting, so we're going to have a reaction force. And they're connected by some tension. Remember, tension always points away from the particle. The coefficient of friction is mu, and after release, the particle of mass 4 kg is moving up. So it's accelerating this way, so that means friction is going to oppose it. Now remember, the question I always ask you guys to ask yourselves is, friction, is it at its maximum or not? Well, because it's moving, friction has to be at its maximum, so we're going to use mu r. Okay, show that the acceleration is this for 7 marks. All right, the first thing we're going to do is going to resolve this force. It's going into the ground and down the hill. Remember, this angle 30 is the same as this one. Now we just resolve the forces. This is going to be the adjacent one, so it's going to be 4g cos 30. And the opposite, 4g sine 30, which is just a half. We cross that off. All right, so let's focus on this one. What are we saying? We've got out the ground, into the ground. So out the ground is r, into the ground is 4g cos 30. So r is 4g cos 30. Cos 30 is root 3 over 2, so we get 2 root 3g. So that's dealt with, and that is dealt with. Remember, if that's accelerating up, this is also accelerating down. Then we're going to say t, so here we're moving, right? So moving in this direction. So we're going to say t, subtract this, so F equals ma, we're doing the net force. So t minus these two, in fact, I'm going to do that here. T subtract mu r. Now we have that, that's going to be 2 root 3 g mu. Yeah, so that minus this, that'll be minus 2g, equals the mass, which is 4a. So that's looking at the first particle. With the second particle, looking at the up and down, there's only movement. So it's the positive force is moving down, 5g. Subtract t is the mass, 5a. Everything's ticked, I'm happy. So we're going to add these two to cancel out t. If the t's don't cancel, you've done something wrong. So we are left with 5g minus 2g, which is 3g, minus 2 root 3g. Mu is 9a. From here, we can factorize out the g and divide by 9. We get 1/9. 3 minus 2 root 3 mu. Take out the g. And hope it's the same. 1/9, 3 minus, easy. 7 marks for that. Guys, mechanics super generous. Part B, find the range of values for mu. Now obviously it's going to come from here. We know that if it's accelerating, A is going to have to be positive. We've defined this way to be positive. A can't be 0 because then it would have just remained still because it started from rest. Okay? So we're going to say this bit here is bigger than 0. That's nice because we can times both sides by 9. That just gets rid of this. We can divide both sides by g. That gets rid of this. Move that to the other side. We get 3 is greater than 2 root 3 mu. So mu has to be less than. So mu is less than 3 divided by 2 root 3. 3 divided by 2 root 3 is root 3 over 2. And obviously you can say mu is bigger than 0, but you don't have to say that if you don't want to. 3 divided by 2 root 3. Yeah, all good. Part 2. Given that mu is a half, find the tension in terms of g. So you can work out the acceleration now. So if mu is a half, a is 1/9. 3 minus mu is a half of 2 is 1. So you just get 3 minus root 3. G, right? And then we just need to plug into one of these. I think this one is the easier one, right? So T is going to be 5G minus 5A. So T is 5G minus 5 lots of this would be 5/9. 3 minus root 3 G. Now the way they want it in terms of G, so all we could do is we could factorize out G and then deal with the inner bit. So we have G, we're going to have 5 minus 5/9 times 3 plus 5/9 root 3 G. 5 minus 5/9 times 3 is 10/3. 10/3 plus 5/9 root 3 G. Now we can obviously make that look cleaner. I don't like that. What we can do is we could times top and bottom by 3 to make a common denominator. So we get 30/9. And then we can factorize out the 9 in the denominator. And we could take out a 5 from the numerator. So the 9s would go. Dividing that by 5, we're going to get 6 plus root 3 G. Nice. And then finally, part D. Show the magnitude of the force on the pulley is 5/9. So show the magnitude of the force exerted on the pulley is this. Now, we can do this in many ways, but I'm going to show you guys a derivation, which I recommend you remember for the exam. So, what's going on in the pulley? Right now, we've been focusing on the particles, right? And we know all forces need to act away from the particles because they're the subject of our focus. However, when the subject of our focus is the pulley, the forces now need to point away from the pulley. Focusing on the pulley, what's happening? The strings are actually pulling down at the pulley. The tensions are actually facing away this time from the pulley. Now, I like to describe this to my students as, imagine that's a conker. You know the conkers, and you smack each other with the conker in that. So imagine you have a conker, and you have 2 strings, and you pull with equal force this way. Which way is the conker going to move? It's going to move right down the middle. And that's what they're talking about, the magnitude of the force on the pulley. We need to calculate what the magnitude is of this force. Okay, it's looking a bit messy, isn't it? So for that, we only need the tension, but let me derive it for you guys with a new picture. It's all just simple trigonometry. Like I've told you guys many times, all of mechanics is simple trig. Now I'm going to derive it generically for you guys, and then we're going to make some substitutions, okay? So, sorry, this is part D. Save myself there. Because this is 30 degrees, it's going to be much easier. This is why we can do it exactly. But let me show you guys how it works generically. Let's call this alpha. We have a pulley, and we have these 2 tensions pulling this way and this way. And we said, if they're pulling the pulley equally in these directions, it's going to go down the middle, right? So what we've got to do is we've got to find what this force is based on this direction. Now, this is a right angled triangle, right? So alpha 90, this whole force here, or this angle, sorry, would be 90 minus alpha. This angle here would be 90 minus alpha over 2. And we've got resolve this tension in this direction. Resolving means draw a right angled triangle where tension, the thing you're resolving, is in the hypotenuse. So we just draw a right angle to this. It looks something like that. T is in the hypotenuse now, and we want the adjacent side. Now the adjacent side would be cosine of the angle. So it's going to be T cosine of 90 minus alpha over 2. So F is going to be T cosine of 90 minus alpha over 2. But then we have to do it for this T as well. It's going to be 2T, and that's it. This is what I recommend you guys remember. Okay, you can derive it super easily, but if you could just remember it, you're sorting your life out much simpler. Now, alpha in our case is 30. So F is 2T, which is this, which actually I can just do it now. And this will make me realize if I've actually done this correctly or not for part C. If I double this, I get 10 over 9 cos of 90 minus alpha is 30 over 2. 90 minus 30 is 60. 60 divided by 2. Oh, wait, hold on. 10 over 9. Sorry, I didn't write the 6 plus root 3g. 6 plus root 3 g cos 90 minus 30 over 2. All right. So, I actually don't need this anymore. From here, I'll know if I even done it right. If I haven't, I'm cooked. So, what is this? Cos of 60 over 2. This is cos of 30. Cos of 30 is root 3 over 2. So, f is 10 over 9 times root 3 over 2, 6 plus root 3 g. The 2 cancels the 9, 2 cancels 10, 5, root 3. Now, just looking at their answer, they just have 5/3. It looks like they multiplied in the root 3, because we have 5/9 root 3. So, I mean, there's many ways we can do this. I'm just going to multiply in the root 3 and then factorize out the 3 after. So we get 5/9. I think I can see the answer, thank God. Root 3 times 6 is 6 root 3, plus root 3 times root 3 is 3, g. Then factorize out the 3, we get 5/9 times 3. Then here we're going to get 2 root 3 plus 1, g. Then the 3 cancels the 9 3 times. And there is our answer. And I'm a very relieved man because this has been, I assume, a long video. But we've learned many things. It looks good to me. So yeah, that is that. I mean, that being 5 marks and that being worth 7 is kind of crazy because, you know, even though probably this had more steps, I would say this was the hardest part. But yeah, guys, we did a lot of things in this video. If you learned something, I'd really appreciate if you hit the thumbs up button, subscribe for more maths content, and if you're interested in my A-level maths courses, there is a link in the description, and feel free to join the Lung Gang Reddit to submit your questions and get feedback from the community. I'll see you in the next video. Nice.